Hey, grade 11s. So we are looking at the second question, which is a lawnmower analysis. So looking at the question, we have a homeowner, so the person, he's accelerating a 15 kilogram lawnmower uniformly from rest to 1.2 meters per second, right in 2 seconds. We also know that the coefficient of kinetic friction is 0.25. So that means that the lawnmower is in motion. Calculate the horizontal applied force acting on the lawnmower, and then upon completion, draw an FBD or free body diagram of the lawnmower. So in this case scenario, we're kind of working backwards. We're starting with our kinematic equations, and then we're trying to find acceleration. Thereafter, we're trying to find any of the forces for the F net, and then any of the forces, and then drawing our FBD or our free body diagram. So let's write down our givens. So initially we have it starting from rest. So initial velocity is 0 meters per second. And that's because it's starting from rest. It goes up to a final velocity of 1.2 meters per second. And that is towards the right direction. We also know that the time that it takes is 2 seconds. And the final part is what we need to find is from your kinematic equations, you'll always note 3 of the values in some way or some form. And the fourth one is what you're going to be calculating. So what we're going to be trying to calculate is our acceleration over here. Now, based on these 4, we can use our kinematic equation, which has all 4 of these inside of it. So the one that we're going to be using is final velocity equals to initial velocity plus a delta t. What we can do is we can bring this to the other side. So it's going to be final velocity minus initial velocity equals to acceleration multiplied by time. And since we're solving for acceleration, we can divide the left-hand side by time. And we are left with acceleration. So now it's just a matter of us plugging in our values over here. So our final velocity is 1.2 minus our initial velocity, which is 0, divided by 2 seconds, and that will give us our acceleration. So our acceleration is therefore equal to 0.60 meters per second square. And since it's a vector, it needs a direction. And since it is being pushed to the right, our velocity or the motion is going to the right, our acceleration is also going to be towards the right direction. Now, we have our kinematic equations, we have acceleration. The next part that we can do is our net force. So over here, we can do F net is equal to mass times acceleration. Now, there are 2 forces. In order to do this, we can do both the F net and FBD together. So let's draw our free body diagram to get a clear picture. We have gravity acting downwards. We have normal force acting upwards. And these two in our y direction, they can cancel each other out because the object is not moving in our y direction. The object is moving in our x direction. The object is pushed this way, so this is going to be our F applied. And there is going to be kinetic friction that is going to oppose this motion, which is going to be in the opposite direction. So the 2 forces that we're going to be focused on is our kinetic friction and our applied force. So in terms of our F net, we are going to specify our right direction. Anything to the right is going to be positive. So therefore, in terms of our net force, it's going to be F applied minus our force of kinetic friction is equal to mass times acceleration. Now, over here, the question's asking us to calculate the horizontal applied force. So we don't know what the horizontal applied force is. That's what we're looking for. We have mass, we have acceleration from the previous part. We need to calculate kinetic friction. So in order to calculate kinetic friction, let's choose a different color. In order to calculate kinetic friction, the formula is mu k multiplied by normal force. Now, mu k, normal force, is opposite of gravity, so that is going to be multiplied by m times g. You can plug in our values now. So our mu k value that we have is 0.25. So 0.25 multiplied by the mass of the object, which is 15 kilograms, multiplied by gravity, which is 9.8. So our kinetic friction is going to be equal to 36.75 newtons, and the direction that the kinetic friction is going to be towards the left. Now, over here we have kinetic friction towards the left, or we can also say, we'll leave it at that. Now, for the next part, our F applied is what we're solving for. So our applied force, we can take kinetic friction to the other side. So it's going to be mass times acceleration plus kinetic friction. So our applied force is equal to our mass, which is equal to 15, multiplied by our acceleration, which we have from the previous part, which is 0.60, plus 36.75. So our applied force is now equal to 46 newtons, and the direction of the applied force is towards the right, so we also have to give it a direction since it is a force and a vector. One thing to note when solving this question is that do not round until the very end. Okay, so the 36.75, use all digits throughout, or else your answer will be slightly different at the very end.